Hello everyone, welcome back to my channel. Today we're going to start we're going to do a test. We're going to do actually a complete application, but first I want us to have a look at some theory, because I want to make a sentiment analysis tool, but I want us to learn a little bit about this. So first thing, I just opened a workflow, a new workflow, and I created a form. On form submission review. The label I put your name, and on the text input I put review. So now when you execute, it's going to show like this. So when a user enters the name, his name, and the review, then what it will do is this application that we're planning to build is actually going to check, analyze it, whether it's a good. Then it's going to put it in a sheet, whether it's a good review, positive review, or negative review. Okay, so we have to use something called basic LLM chain. Okay, so let's talk a little bit about basic LLM chain to understand it first. So what is the basic LLM in n8n? The basic LLM chain is a node n8n that acts as a bridge between your workflow and the AI model like GPT or open source models such as DeepSeek or LLM. It does four main things: receive input, sends it to an LLM, structure the message type, user, system, assistant, returns output back to the workflow. Okay, that's what basic LLM does. It basically connects your workflow to an AI model in a controlled way. Why it's important? It's especially useful when working with open source models, because unlike OpenAI nodes, you must manually define message types. You have more control over how the model behaves. You can also use AI agent node, more advanced, or basic LLM chain, simpler and more direct. So we receive an input sent to LLM, structured message type. We have different type: user message. User means message that are sent by the user. System means message that are sent by the system. They returns an output back to your workflow. So it's especially useful when working with open source models, because unlike OpenAI nodes, you must manually define message types. You have more control over how model behaves. You can also use AI agent node, more advanced, basic LLM chain, simpler and more direct. So basically we are going to use basic LLM chain. So the type of message in the LLM chain will have three types: the user message, it's the user input; system message, rules or instructions for the AI, like a prompt basically. Okay, assistant message, previous AI response context. Key parameters in basic LLM chain: we have user input, it's the prompt. This is what you send to the model. You can take it automatically from previous node or define it manually. Okay, and we have chat message. Here you can define system instructions, rules for the AI, extra context, or assistant message. So the output format: by default LLM returns plain text and structured data. Okay, this is a problem because other nodes cannot easily use it. Okay, we use parsers to convert output into structured data. Okay, so what they mean by unstructured data means plain text, right? But we can't, other nodes will not be able to use the plain text. So we have to use the parsers to convert the plain text to the structured data. Structured data means JSON format, like this, JSON output, which is, so auto-fixing output parser. It will fix small mistakes in JSON output. Example: missing quotes, broken JSON format. It's almost correct but slightly broken. Item list output parser converts text into list of items. We have example. here. This is basically the input. Okay, this is the output. Okay, the output is basically this one. Item, apple, banana, orange. These are the output. So you see this one, this is structured basically because it's in JSON format. It's useful for email list, bulk processing, multi-step workflow. It's not a JSON format, but it's structured. Structured output, convert text to a list. Okay, so structured output parser, this forces the model to return clean JSON structure like this. Okay, base for APIs, databases, Google Sheet, automation workflow. Basically, this is what we will focus on. Structured output parser. Why parser matters? Without parser, output is equal to plain text, hard to use with other nodes. Parser output is structured, can be passed directly to other nodes. So, like for example, if you don't use parser, this is what you will get. My name is Mohammed. But if you use structured parser, you will get this one. So now you can store it in Google Sheets, send it to Gmail, use it like this. Let you control the message type. And parsers are what transform AI text with this one. So this is an LLM. Okay, so this is what happens. Okay, so I'm going to add here the I'm going to use something called merger. Okay, the reason to use merge is actually to merge data from multiple sources. Let's say you have multiple inputs, you want data from both those inputs. Okay, so like for example, I want the first input to be I want this, remove this one. I want first input to come from the Google form, and the second input I want it to come from basic LLM chain. Okay, the reason is because when we configure basic LLM chain, okay, let me show you now. Here in the prompt, here is the user message, right? We care about the review. That's it. We copy this one, we paste it here. Okay. No, we have to change this. It says connected chat trigger defined below. Okay, then you just copy this one, the review, and paste it here. Okay, and then you're going to add prompt here. Okay, so here we mentioned the review, this is what we care about, and here we will mention the prompt. My prompt, I'm going to go to get it here. I think this is the prompt that I used. So you are a sentiment analysis assistant. Your task is to analyze the following customer review, classify the statement as one of the 3 natural reviews, positive, negative, and return only positive, negative, or neutral. Do not explain your answer based on result of overall system. So that's it. So I'm just going to copy this review here and paste it here, or keep it here. I'm just going to copy the review here and paste it here. Okay, so this is the review. So this is going to check with the LLM, okay, and give us a response. Okay, from here, so the idea is from here, let's execute it. The models have not must be enabled. So I think what we need to do here is actually connect. Go here and type add Olama chat agent. Olama, go here, Olama chat model. Choose DeepSeek, okay, the one that we downloaded, and close. And this one we're going to add it here to the model. So now let's try to execute. Okay, when we execute this, we should be green. It's green, so it's fine. So now what happened is we got the input from the form and from the LLM reply to here. You see here, positive. The answer is positive, right? Because the review is actually the food tastes good, James review, and the LLM we got positive. The reason we use merge here is because we need the name, right? We can't just use here, and the LLM is just going to take the review, whether it's positive or not positive. But to take the name, we have to merge two outputs, two different outputs here. Okay, then here I'm going to add Google Sheet. Google Sheet here, append the row and sheet, put it here, go to reservation and sheet. Okay, here the name I'm going to mention on the form here, I'm going to mention here the name, and the review I'm going to mention here, the review. Okay, then I'm going to execute. Once I execute it here, okay, this is what happens. It's going to add. Now you can go here and yeah, we got it here, right? Automatically it was updated on the here actually there's a mistake. The reason is because I didn't put it correctly here. On the review side, I took from the form submission. I should take from the LLM, right? That's what we want. So let's execute it again. Okay, go here. Yeah, James positive. That's it. So this is the idea. So let's try to execute the workflow again. Let's try here, mention Sami. Okay, and the review, the food was salty and had too much salt in it. So let's submit this one, and now let's see what we get. Let it do its job and go to the reservation. Let's see the reply from Sami. Yeah, we got it right. Sami here, negative. So it analyzes, it checked the sentiment of the inputs that I gave it, and then it's replied to me negative. So we just actually built our first full AI agent. Okay, so we will check it now, and now what I want to see is actually I want to see more on this one. Okay, overview of the lecture. The lecture explains extremely important topic: how AI companies price their models and APIs. The structure focuses mainly on DeepSeek pricing, but the same concepts apply to companies like OpenAI, Gemini, Anthropic. Previously, the course explained open source LLMs. Open source model can run locally, usually free, but may lack advanced features. Okay, Paid model like GPT, Gemini, DeepSeek APIs run on no, I think we already talked about this. No, we didn't actually. Yeah, at this point we talked about it, and we said that the paid models like GPT, Gemini, DeepSeek, they run on company servers. You can access them through APIs, usually support advanced features like function calling, better reasoning, all this stuff. If your project needs advanced AI capabilities, you often need paid API. I showed you in the previous video how to set it up with OpenAI, but you need to add credit. Why do AI companies charge money? Because the models run on expensive servers and GPUs. Your workflow, for example, from n8n sends a request to the company API server. The server receives your request, runs in the AI model, sends back the response. Okay, like sends back the response. You're basically paying for the compute power, GPU usage, memory, and infrastructure, right? Tokens also is an important concept. AI companies charge based on tokens. A token is like a word, part of a word or number or punctuation. Think of token as roughly a word. So hello, maybe one token. Unbelievable could be multiple tokens. There are two things companies charge for input companies. The text you send to the model. Example, translate the sentence to French. The response generated by the model. We have this one, bonjour, comment ça va. DeepSeek model types. The lecture explains two main DeepSeek models. We have DeepSeek chat. This is similar to regular chatbot behavior, faster response. Equivalent to V3. DeepSeek reasoner. This is a reasoning model. Think about before answering. Equivalent to DeepSeek R1. Yeah, this is different types of DeepSeek models. Reasoning model are usually smarter, better at logic, more expensive. And we have something called context window. I think we have talked about it. We said like it's like a RAM, or it's temporary holds the current conversation. All mean roughly the same thing. Total allowed token, context length. This one you may hear context window, context length, token window. Total allowed token in one API call. So input is 1000 token, output is 1000 token, total context is 2000 token. Okay, that's the idea of context length. Okay, so DeepSeek chat limit, we have context window. Let's say it's 64k token, meaning input output together cannot exceed 64k. DeepSeek reasoner difference. For reasoner model, output token are not counted toward context length. You can use 64k plus large output separately. It effectively gives you much larger usable context. Max output token. Models also limit how much text they can generate. Example, default output limit 4000 token. Maximum we have 8000 token. If succeeded, you may get translation error. You choose model based on the use case, what the model is good at: coding, video generation, image generation, translation, speech, reasoning, such as function calling, JSON output, tool calling. Yeah. Pricing, you must understand token pricing, context limits, output cost, especially in production system. Peak versus off-peak pricing. DeepSeek uses peak pricing, off-peak pricing. During off-peak hours, discount can reach 50 to 75%. So timing affects cost. Peak pricing and off-peak pricing. Discounts can reach 50 to 75%. Discount can reach 75, 50, so timing affects cost. Cache hits versus cache miss. This is another critical concept. Cache miss: when the model sees the prompt for the first time, translate this to English sentence into French. System must process everything from scratch. Uses more compute. Peak pricing, off-peak pricing. During off-peak hours, discount can reach. Okay, so timing affects cost basically. Cache miss: when the model sees a prompt for the first time, must process everything from scratch, uses more compute, so cache miss is more expensive. When the same prompt already exists in cache or memory, the system reuses previous competition, responds faster, costs less. So cache hits are reuse previous competition, responds faster, costs less. Important detail about cache: cache works only if prompts is nearly identical. If you change hello how are you to hello where are you, then it may become cache miss. When the same prompt already exists in cache memory, the system reuses previous competition, responds faster, costs less. Cache hit is cheaper. Cache works only if the prompt is nearly identical. If you change per million token, AI company usually show prices like 1.10 per 1 million token. Calculate single cost. In production system, cost scales fast. Thousands of users generate millions of tokens. A company estimates monthly token usage, peak usage. Understanding pricing becomes essential for SaaS or AI agent automation. Pricing is usually per million tokens, like $1 per 1 million token. Where to find official pricing? You can check DeepSeek API, go to official model and pricing. You can find there all these details. Choose an AI model. Pricing: after choosing the right model, technically you must check this one. Instruction how to access Gemini pricing. Search for Gemini API, then open documentation. You'll find all Gemini pricing. Gemini has many models. We have Gemini 2.5 Pro, Gemini Flash, Gemini 3, Gemini 3n, and more. Each model differs in capability, speed, use case, and pricing. So Google provides two pricing modes: free tier used for testing, learning, small experiments. Paid tier used for real production system, much larger token limit, stable usage, production grade access. The lecture uses Gemini 2.5 Pro as an example. It's described as multi-purpose, strong reasoning, good for coding, handles multiple tasks. So input token pricing: companies charge for input and output token. Text you send to the model, the monthly under 200k token cheaper rate, above higher rates. Unlike DeepSeek, smart output tokens are AI response returned to you. Google charge separately for output token, more expensive than input. Gemini context 1 million token. APIs enormous compared to this. This works similarly. Prompt already exists. Caching works only when the prompt is almost identical. Small changes to return. Cache hits. Google charges not only for cache hits, also for strong meaning. Restore this one. Gemini supports something called grounding via Google search. The model can search live up-to-date information from Google, useful for news real time. Point mentioned. Google charges not only for cache hits, but also for storing cache prompts, meaning cache data consumes memory and resource. Storing itself costs money. To store 2,000 for 1 hour, you pay cache storage fees. Only when prompt is almost identical. Small change in return. Allows to search free. The data addition search costs money. Gemini Flash models, we have these models, are faster, cheaper. Anthropic, also we have inputs. Main lesson for the entire, we decide what the application we want to build, then compare the features, context size, pricing, speed, reasoning ability. Sometimes open source model is maybe enough, saving you significant API cost. AI pricing mainly depends on this. So I think this is about enough. We can go and see what more on the, let's say, DeepSeek pricing. DeepSeek pricing. DeepSeek pricing we have here. And or we can check AI also, this topic. Gemini pricing API, right? We need we have free limited access, paid we have also. Here we have Enterprise 3.1 Flash. We'll be able to find many more pricings here, but the concept is we just have to make sure we did our checks before performing the thing. Thank you for watching.